Morning, all of you. Today's lecture we will discuss Cauchy integral theorem. Cauchy integral theorem. So let f of z be analytic function. The analytic function within and on the closed contour. Closed contour and f dash of z is continuous, then integral over c f of z dz is always 0. That is our statement of Cauchy integral theorem, right? So proof is also very easy. So let's see. So f of z is analytic function they given, right? So f of z is analytic function. Analytic function. So our f of zb is in the form of u plus iv, right? Where u is real part and v is imaginary part. Since f of z is analytic, it satisfies CR equations, right? It satisfies Cauchy-Riemann equations. Cauchy-Riemann equations. So what are the Cauchy-Riemann equations? Dou u by dou x is equal to dou v by dou y, and dou u by dou y is equal to minus dou v by dou x. So these equations are called Cauchy-Riemann equations, and also these partial derivatives are continuous, right? Now, so what is f of z dz? The f of z dz is nothing but u plus iv into, so dz is dx plus I dy, dx plus I dy. So which is equal to, see, you multiply u dx plus I into u dy plus I into v dx plus I square v dy. Since I square is minus 1, so this can be written as u dx, and so I square is minus 1, na? It is minus v dy plus, so if we take I common, u dy plus v dx, right? Right. Then integral over c f of z dz is equal to the integral over c u dx minus v dy plus I times of integral over c v dx plus u dy, right? So this is our equation 1, let it be, right? Then by using Green's theorem, by using Green's theorem, so what is the Green's theorem? It is m dx plus n dy is equal to double integral for the reason are dou n by dou x minus dou m by dou y. It's dx dy, right? Now we applied for these two. So that means integral over c u dx minus v dy can be written as, see, dou n by, so this is m, treat it as m and treat it as n. So that means dou n by dou x means minus dou v by dou x, right? And then minus dou m by dou y, that means it is dou u by dou y, dx dy, right? So then since f of z is analytic, it satisfies CR equations. Then so what is dou v by dou x minus of dou u by dou y na? That means it is minus minus plus. So this can be written as dou u by dou y minus dou u by dou y dx dy, right? So this is nothing but equal to 0, right? So similarly, our next concept is integral v dx plus u dy. Integral v dx plus u dy over c is equal to, see, this is treated as m, this is n. By Green's theorem you write it as dou n by dou x, that means dou u by dou x, minus dou m by dou y, that means dou u by dou y, right? Is dx dy, right? So which is equal to, see, since again f is analytic, it satisfies CR equation. So dou u by dou x can be written as dou v by dou y minus dou v by dou y. So which is dx into dy, right? So now which can be written as, see, this is 0 now. Now equation 1 becomes, that means total integration, integral, so from equation 1, from equation 1, what is integral, see, f of z dz is equal to 0 plus 0, that means it is 0, right? Uh, this is our proof. So first you have to remember the statement clearly. See, f of z is analytic within and on a contour C, that is our first point, and f dash of z is continuous, second point. Then so what Cauchy's theorem says, that integral f of z dz is always 0, right? We can see the problems. Evaluate integral z square minus z plus 1 by z minus 1 dz, where c is nothing but mod z equal to 1 by 2 is taken in an anti-clockwise sense. Anti-clockwise sense. See, so the solution is, what you need to find, integral over c z square minus z plus 1 by z minus 1 dz. So where the circle is given, see, that circle is mod z equal to 1 by 2. So already we know that it is a circle with the center 0 0 and radius is 1 by 2. So this is circle with the center 0 0 and radius 1 by 2. Radius 1 by 2, right? So that means suppose if we draw a circle with the radius 1 by 2, so this radius is 1 by 2, right? This is your radius, so that means here is 1 by 2 comma 0 point, right? Now see, compare with the integral c f of z dz. So where f of z is z square minus z plus 1 by z minus 1, right? So now we need to check whether the function is analytic within that region, that circle region, or not. So there is only one difficulty, which is when z equal to 1. So when z equal to 1, this function becomes infinity, right? So there is a difficulty, right? Now check whether this z equal to 1 lies inside or outside the circle. Inside or outside the circle. So z equal to 1 means 1 comma 0 I, right? So that means see, The 1 comma 0 I is lies here, right? So this is 1 comma 0. That means so this point is outside the circle. So it does not belongs to the circle. So that point is outside the circle. So z equal to 1 is outside the region. So therefore there is no problem of not analytic. That means it is analytic in the whole circle. Since z equal to 1 lies outside the circle, outside the circle, right? Outside the circle. So therefore f of z is analytic within and on a closed contour C, so which is mod z equal to 1 by 2, right? Right, you can verify that point by substituting our z equal to 1. If you substitute z equal to 1 here in this circle, so what you get modulus of 1, so which is 1. So 1 is greater than 1 by 2, right? It is clear. So greater than 1 by 2 means that point lies outside. If it is less than 1 by 2 means that point lies inside. For suppose mod z equal to 2, mod z equal to 2. So you need to check where the point z equal to 1 lies inside or not. Directly you substitute modulus of 1. So which is less, which is equal to 1, less than 2. That point lies inside the circle, right? For suppose z equal to 2 is there, 3 is there, then modulus of 3, so which is equal to 3. 3 is greater than 2, right? So therefore z equal to 3 lies outside this circle, right? If it is less than, inside. If it is greater than, outside, right? So you can check by that process also, right? Therefore the function is analytic and by using Cauchy integral theorem. Therefore by using Cauchy integral theorem, we conclude that integral C f of z dz is equal to 0, right? That means integral C z square minus z plus 1 by z minus 1 dz is 0. We go for the next problem. Evaluate integral C e power 2z by z minus 2 dz, where C is mod z equal to 1. C is mod z equal to 1, right? Now compare this with the f of z dz. So what is f of z? E power 2z by z minus 2. Now you need to check z equal to 2 lies inside the given region or not. So given circle is mod z equal to 1. So the point now z equal to 2 lies inside or not, na? So that means modulus of 2, which is equal to 2, it is greater than 1. So therefore z equal to 2 lies outside the circle mod z equal to 1, right? It is clear. So therefore we can say that f of z is analytic within and on the closed contour mod z equal to 1. So therefore by Cauchy integral theorem we can write Cauchy integral theorem, we can write integral over C f of z dz is equal to 0. Integral C f of z dz is 0. So that means take all c e power 2z by z minus 2 dz is equal to 0. Right? So this is by Cauchy integral theorem.